Hello, my dear students. Today we'll try to learn how to calculate work done by a variable force. Okay. Say we know that. See, if you plot a graph, force versus displacement. Okay, force versus displacement. We drew a graph, and say there is a constant force F acting on a particle through a distance or displacement equal to x. Now, what is the area under this curve? Okay, so how to find the area? Area is equal to length into breadth, F into x, correct? Now area is equal to F into x. But we also know that work done is equal to force into displacement. What does it mean? Area under force versus displacement curve gives work done. Okay. Now finding the area is easy, okay, when force is constant. What if, what if force is not constant? What if force is variable? Say we consider a variable force which depends on x. Okay, force is not constant. Say force is something like this. Now, in order to calculate work done, we have to calculate area under this curve. Correct now? We have to calculate area under this curve. But here this is not a trapezium, this is not a rectangle, this is not a triangle. Okay. So now what to do is we have to use calculus. First, see what we have to do. We have to consider a very one small rectangle here. Okay. Say this distance is delta x. This delta x. Now this almost looks like a rectangle. Here we are missing out little amount of area, little, but almost looks like a rectangle. Okay. Now see, corresponding work done, I call it as delta W. Okay. Now this is important. Here you have to concentrate. What is delta W? Delta W is the small work done during the displacement delta x. Delta W is equal to F into delta x. Okay. Now, in order, see, in between these two lines, say this is the initial position, this is the final position. Here, there are many delta x's. Okay, delta x, delta x, delta x, delta x, delta x, delta x, delta x. Correct now? To calculate total work done, okay, to calculate total work done, you have to add all those small delta w's between initial position and final position. Correct now? You have to add all those small delta w's. Okay, so delta w plus delta w plus delta w plus delta w plus, then you will get total work done. Correct now? So that is equal to, work done is equal to summation of what is this, F into delta x between the limits xi and xf. Now here there is a interesting part. Okay, now this is not exactly equal to, this is approximately equal to. Correct now? This is approximately equal to. Why? Because see here we are missing out one small area here. Correct now? This area we are missing out. Area under the curve is not exactly equal to sum of all the rectangles. Now what we are trying to do is, we have divided this area into many rectangles. Correct now? Delta x, delta x, delta x, delta x, delta x. Now sum of areas of all these rectangles, is not equal to area under the curve. Why? Because we are missing out this area. Correct now? So that is why sum of areas of all the rectangles is approximately equal to area under the curve. Say let us suppose that these rectangles are bigger. Okay, say these rectangles are bigger. It's very important, understand. Say these rectangles are bigger. Say I have got only two rectangles here. Now here I get one rectangle, here I get one rectangle. Now what happens? The missing area is large. See, we missed this. Here the missing area is less. Here the missing area is large. Now this is delta x here. Okay. Here in this case delta x is small. What does it mean? It means if you keep on decreasing delta x, area under the curve will be approximately equal to areas of sum of areas of all the rectangles. Now here, okay, here area under the curve, okay, is not equal to sum of areas of all the rectangles. Okay. Now here area under the curve is approximately equal to sum of areas of all the rectangles. Why? Because we are reducing delta x. Then what does it mean? If delta x tends to 0, okay, if you make the delta x very small, it becomes dx. If delta x tends to 0, then area under this curve will be exactly equal to sum of areas of all the rectangles. This is very important. Okay, so that is why what do we do? See here, what is the final expression that we got? Work done is approximately equal to, okay, work done is approximately equal to, yeah, work done is approximately equal to summation of f into delta x between the limits xi and xf. Now when delta x tends to 0, what happens? When delta x tends to 0, this summation becomes integral. Okay, then work done will be equal to integration of f into dx, because this delta x becomes very small. Then we have to write it as dx, because dx means very small displacement. Okay, between the limits xi and xf. The meaning of summation and integration both are same. Summation means adding, integration also means adding, I have told you. Okay, between the limits xi and xf. Okay, so this is how you have to calculate work done, okay, if there is a variable force. Now we will try to understand using a simple problem. Okay, there is a force, okay, which is acting on a particle in x direction. Okay, force acting on a particle in x direction. Find the work done by this force during a displacement of x is equal to 0 to x is equal to 2 meters. So what is the formula that we have? We have work done is the definite integral of force over displacement between the limits xi and xf. So they have given the force, they have given the initial position, they have given the final position. Correct now? So what do we do? So work done is equal to integration of 2 plus 3x with respect to x between the limits 0 and 2. Okay. Now what is the integration of a constant? Integration of a constant is constant into x, if you remember. So integration of a constant with respect to x is equal to constant into x. So what happens? So integration of 2 with respect to x is integration of 2x plus integration of 3x. Integration of 3x with respect to x will be equal to 3 goes out, correct now? 3 into integration of x with respect to x. X means x power 1, correct now? So integration of x power n is equal to, with respect to x, is equal to x power n plus 1 divided by n plus 1. So what happens? 3 into integration of x power n is integration of x power n plus 1 means 1 plus 1 2 divided by 1 plus 1 2. So 3x square by 2. So what happens? 2x plus 3x square by 2. Okay, so I should so after integrating I should not write integration symbol. Okay, 2x plus 3x square by 2. Now so between the limits, okay, after integration you are writing the limits here on the right side. Okay, so this is equal to this is equal to, first you apply the upper limit, then you apply the lower limit, correct now? So 2 into 2, 2 into 2 plus 3 into 2 square by 2, 3 into 2 square by 2, okay, minus, then you have to apply lower limit. When you apply lower limit, here it will be 0, here also it will be 0. In the place of x, you have to substitute 0. So it will be 0 only, okay. So therefore, when the lower limit is 0, you don't have to apply the lower limit only, okay. 2 into 2 is 4. So 1, 2 and 2 gets cancelled. 3 into 2 is 6. 4 plus 6 is equal to 10. 10 joules. Work done is equal to 10 joules. Hope you can understand. When there is a variable force, how to identify? If in the equation of F, if there is x, then what does it mean? F depends on x, correct? Then F varies with x, so that is the meaning. So if there is a, if force is given wherein in terms of x, then you should understand that it is variable force. As the distance changes, force also changes. In the case of variable force, you have to use the equation work done is equal to definite integral of force over displacement, okay. So hope you understood the concept. So we wanted to calculate area. Since there is variable force, we don't get rectangles directly. So therefore, what we have to do, we have to consider a small portion and we have to calculate the small work done. Okay. So if you have to calculate total work done, you have to add all those small work dones between initial position and final position. Then you will get total work done. And but that is approximate, because so while doing this, we have missed small areas. These small areas we have missed. Okay. So therefore, what we have to do, in order to get the exact answer, this delta x has to be made very, 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 very small. We have seen when the delta x is bigger, sum of areas of the rectangles was not equal to area under the curve. So therefore, what we have done, we have applied limit to this delta x. As delta x tends to 0, as delta x tends to 0, what happens? What happens? So we will get the exact answer. Okay. Hope you understood the calculation. Thank you very much.